Hello everyone, I'm Dr. Steve Warner, and today I would like to talk about geometric sequences. Let's start by looking at an example. 1, 2, 4, 8, 16, 32, and so on. Notice that the first term of this sequence is 1, the second term is 2, and so on. Also notice that to get from 1 to 2, we need to multiply by 2. To get from 2 to 4, we also multiply by 2, and so on. This number 2 is called the common ratio of the geometric sequence. So why is it called a common ratio if we're multiplying? Well, because another way to find the common ratio is to divide any term by the previous term. For example, 2 over 1 is 2. Or 4 over the previous term of 2 is 2, 8 over 4 is 2, and so on. So a geometric sequence is a sequence of numbers such that the quotient r between consecutive terms is constant. This number r is called the common ratio of the geometric sequence. So for example, the geometric sequence 1, 2, 4, 8, 16, 32, and so on, has a common ratio of 2, as we've just seen. Let's look at an example. The second term of a geometric sequence is 27, and the third term is 81. What is the first term? Okay, well, if the second term is 27 and the third term is 81, notice that to get from 81 to 27, we divide by 3. So if we divide by another 3, 27 divided by 3 is 9. So the first term is 9. Note that in a geometric sequence, you always multiply or divide by the same number to get from one term to the next. And this can be done moving forwards or backwards through the sequence. Note also that in this problem, the common ratio is 81 over 27, which is 3. Don't accidentally divide the wrong way and get 1/3. This particular problem was pretty simple, so we were able to solve it just by counting. In other words, we didn't really have to worry about the formalities of how to find the common ratio, but in harder questions, we might need to be more careful. If we know two consecutive terms of a geometric sequence, we can find the common ratio simply by dividing the second known term by the first known term. But what if we know two terms of a geometric sequence, but they're not consecutive? In this case, we can still find the common ratio pretty quickly in the following way. Suppose g sub n and g sub m are the nth and mth terms of a geometric sequence with m greater than n. Then the common ratio of the geometric sequence is given by this formula here. Okay, there are two ways of writing that: the m minus nth root of gm over gn, or gm over gn to the 1 over m minus n. Now, I realize that formula looks absolutely terrible, but it's actually saying something very simple. So you won't need to memorize this formula, but understanding the steps of how to find the common ratio, you should understand, and it's actually not too difficult. So let's look at this example again, 1, 2, 4, 8, 16, 32, and let's focus in on the 2 and the 16. Okay, notice that the second term is 2, and the fifth term is 16. The first step is to simply divide the fifth term by the second term. 16 divided by 2 is equal to 8. Now that's not the common ratio because these two terms are not consecutive. So the second step is to find the distance between the two terms. So we have the fifth term and the second term, so the distance between them is 3. Now that number gives you the appropriate root to take from the number found in the first step. In other words, we're going to now take the cube root of 8 to get that the common ratio is 2. Note that if we plug these numbers into the formula above directly, we get the following. R equals the 5 minus 2 root of 16 over 2, which is the cube root of 8, which is 2. But again, you don't actually have to memorize the formula. It's much easier just to learn the three-step procedure that I just went over. Let's try another example. In a geometric sequence, the third term is 4 and the fifth term is 9. What is the seventh term in the sequence? Okay, so the first step is to divide 9 by 4. The second step is to find the distance between the two terms, the fifth term and the third term. So the distance is 2. And the third step is we're going to take the square root of 9 over 4, which is 3/2. So we get that the common ratio is 3/2. Now, since the fifth term of the sequence is 9, we can get the seventh term of the sequence by taking that 9 and multiplying by 3/2 to get to the sixth term, and then 3/2 again to get to the seventh term. And this comes out to 81 over 4, which is choice E. The information I already covered is all that most students really need to know, but for completeness, I want to talk about the geometric sequence formula. The geometric sequence formula is G sub n equals G1 times r to the n minus 1, where Gn is the nth term of the sequence. For example, G1 is the first term of the sequence. So let's look at an example here. 1, 1/2, 1/4, 1/8, 1/16, and so on. The first term of the sequence is 1. That's G1. The common ratio we could get by dividing any term by the previous term. It's easiest here to use the first two terms. 1/2 divided by 1 is simply 1/2. So the common ratio is 1/2. So G sub n, the nth term of the sequence, is G1, which is 1, times the common ratio, which is 1/2, to the n minus 1. Or simply 1/2 to the n minus 1. So for example, the 10th term of this geometric sequence is 1/2 to the 9th, which is 1 over 512, since 2 to the 9th is 512. Let's look at an example where the geometric sequence formula is the quickest way to solve the problem. The first and second terms of a geometric sequence are k and bk in that order. What is the 500th term of the sequence? Well, the first term of the sequence is k, and the common ratio is bk over k, which is b. So the nth term of this geometric sequence is the first term, k, times the common ratio to the n minus 1. We want the 500th term of the sequence, g sub 500, so that's kb to the 500 minus 1, which is 499. And the answer choices do not look exactly like that, but since multiplication is commutative, we could change the order and write this as b to the 499 times k, which is choice E.